Problem 3. Find the third column of A times A. So the third column of A times A. So here's the thing. The ith row of A times B is equal to the ith row of A times B. Okay, what do I mean? Let me give you a very simple example. For example, A is just say a 2 by 2 matrix, very simple. B is, okay, again a 2 by 2 matrix, say 0, 1, -1, 0. Okay, anyways, so A times B, we can easily get it. So A times B, first you need to check, right? A is a 2 by 2 matrix, B is a 2 by 2 matrix. The number of rows, the number of columns of A is equal to the number of rows of B. So yes, you can do the matrix multiplication, and the result is going to be a 2 by 2 matrix. So result is going to be a 2 by 2 matrix. Okay, and the first entry, the 1, 1 entry, let's say the 1, 1 entry is going to be the first row times first column. Okay, so just do it. So it's 1 times 0 times plus 2 times -1. The result is -2. The 1, 2 entry, right, first row, second column. So it's going to be first row times second column. It's 1 times 1 plus 2 times 0. Right, 1 times 1 plus 2 times 0 is 1 here. And the 2, 1 entry, right, this times this. The 2, 1 entry, it's -4. And the 2, 2 entry, right, 3, 4 times 1, 0, it's going to be 3. So let's see what does this mean. The ith row of A, B. For example, the first row of A times B. Okay, which is the first row of A times B. It's -2, 1. Okay, is equal to the ith row of A. So the first row of A times B. So what is the first row of A? This is the first row of A times B. B is a 2 by 2 matrix. If you work this out, right, let's do it. So first, can we do it? Always check first. It's 1 by 2. Here's 2 by 2. Number of columns of the first matrix is same as the number of rows of the second matrix. So do it. The result is, right, going to be a 1 by 2 matrix, and the first entry is going to be first row times first column. So it's 1 times 0 plus 2 times -2. It's -2. Then the second entry is the first row times second column. So the result is 1. Right? You can see these two are exactly the same. Right? So in general, it's also true. The ith row of A times B is equal to the ith row of A times B. Okay, it's always correct. So similarly, right? So that's why we can do part B. What's the second row of A times B? It is the second row of A times B. Okay, so copy the second row of A, 6, 5, 4 times B. Okay, do it. First, can you do it? Yes, but let's just check. This is a 1 by 3 matrix. We also call it a vector. Okay, we call it a horizontal vector. Okay, but essentially a vector is also a matrix. It's just a special matrix. It's either its number of rows or number of columns is equal to 1, we just call it a vector. Right? Here is a square matrix 3 by 3, and yes, right, this number is equal to this number. We can do the matrix multiplication. The result should be a 1 by 3 matrix. Okay, then what is the first entry? Is 654 times 607. Just do it. Right, 6 times 6 plus 5 times 0 plus 4 times 7. The result is 64. Right, it's 6 times 6 plus 4 times 0 plus 5 times 0 plus 4 times 7. Right, same thing. The second entry, this row times this column. Just do it. So it is 6 times negative 2 plus 5 times 1 plus 4 times 7. Okay. Just do it. It is 21. Okay, and here it's 654 times 435. Okay, again, just do it. It's 6 times 4 plus 5 times 3 plus 4 times 5. Right. The result is 59. Okay, so the ith row of A times B, we know the first formula. And the second formula, naturally, we also have a formula for the jth column of A times B. Okay, the jth column of A times B is A times the jth column of B. Right? It's A times jth column of B. That's the jth column of A times B. Okay, the proof is very similar to this part. I mean, it actually doesn't need a proof. It's by the operation we did, it's true. It's always true. Okay. So let's say part A, the third column of A times A. So like we said here, it's going to be A times the third column of A. So let's write down what is A. A is this. Okay, what is the third column of A? Third column of A is this. Do the product. Do it. Okay, the result is going to be a 3 by 1 matrix. First entry, this times this. Right, just do it. 3 times 7 plus negative 2 times 4 plus 7 times 9. Right. So the answer is 76. Right. For the second column, you do the same thing. Right. Sorry, for the second entry, you do the same thing. It's the first row times second column. So it's 6 times 7 plus 5 times 4 plus 4 times 9. Right. Do it. It is 98. For the last entry, you do the same thing. It's 97. Okay. So this is part A. And part C, it's a bit tricky. So the first row of AB transpose. Right. By definition of transpose, the first row of AB transpose is equal to the first column of AB. Right? Because if you transpose it, the ith row becomes the ith column. So the first row of AB transpose is the first column of AB. Okay, but this is not exactly correct because the first row is going to be a row vector. Here's the first column, it's going to be a column vector. So after you get the column vector, you have to transpose it, right? You have to put it down to make it a row vector. Okay, to make it a row vector. So you put a transpose here. Then the first column of A times B, it's the first, based on what we have written before, it's going to be A times the first column of B. Then you transpose it. Right, what is A? A is this. What is the first column of B? First column of B is this. Okay, then you transpose it. So to get the result is this times this, plus this times this, plus this times this. Not plus, I mean for each entry. Right, for the first entry, it's the first row times first column. So you just do this 3 times 6 plus negative 2 times 0 plus 7 times 7. The result is 67. Right, do the same thing for the other two entries. You get this one, and you transpose it. If you transpose it, it's 67, 64, 63.